Proof day 4, continuing to review, continuing to build on what we've already learned about two-column proofs. So once again, bisect means to divide it into two equal parts. So if you are told something like, you've got a picture maybe like this, and maybe this is A, B, and we'll call this point D right here. And to be able to talk about angles, I'll need some other points here on those angles. So if we are given something like AB, and I could leave that as a segment, or I could put an arrow on it to say it's a ray, since I have an arrow on the end of that AB there. But if I am told in words to begin a proof, AB bisects angle CDE. So I look at my picture and I find where AB is, and then I look and I see where angle CDE is. So I start at C, I go to D, I turn and go through E. Oh, that angle. Oh yeah, AB cuts through that. That means it cuts it into two equal parts. So what I can say there would be angle CDB, the top half, is congruent to angle EDB or BDE, depending on which way I need it. And I would mark those on my proof as being congruent. And my reason for that would be definition of bisect. So far so good. Give me thumbs up if that's making sense to everybody. I don't see any thumbs up in class or at home. So far so good. Bisect just cuts the segment or the angle into two equal pieces. So here we're going to do it with a segment. So a segment, if it bisects, it cuts it into two equal pieces. So we could say, if this is maybe AC and this is BD, I could, and maybe I'm given BD bisects AC. That would mean AC is the thing that's cut into two pieces. Notice BD doesn't even look like it's cut into equal pieces. It says it bisects AC. That means AC is the one cut into equal pieces. So then I could say AD is congruent to DC or to CD. And my reason would be definition of bisect. Molly? Yeah, I need a different letter. You are exactly right. Thank you for catching that. Be easier if I erase it here. So let's fix that here. That one would need to be E since I already used that up. So I could say AE is congruent to EC. Does that look better now? Thank you very much for catching that. Or I could also say, if I needed it for some reason, E is the midpoint of AC. And that would also be definition of bisect. Depending on what my proof says, here's what you want to get to at the end. Prove this. Because I don't know where I'm going, I don't know which of these things I might need in there. Okay, a little bit of review. We're going to do some proofs where we actually use these. If we have parallel lines, then we know we have a bunch of lines that are congruent in there. So alternate interiors means inside the parallel lines and opposite sides of the other line. And that other line, the big word for it, is transversal. So one pair of alternate interior angles, so my insides are just 3, 4, 5, and 6. 3 and 6 are opposite sides of that other line of that transversal, so angle 3 would be congruent to angle 6. 4 and 5 are my other ones that are inside, and they'd have to be congruent to each other. So far, so good? Okay, alternate exterior means outside the parallel lines. And again, opposite sides of the transversal. Cannon, tell me all 4 angles that are outside of the parallel lines.
1, 2, 7, 8.
So now we're just talking about 1, 2, 7, and 8. Lila, tell me out of 1, 2, 7, and 8, give me one pair that are on opposite sides of that third line. So 2 and 7, do they look congruent to you? So angle 2 is congruent to angle 7. And then if I mark those, that leaves 1 and 8. Notice when you have parallel lines, unless they cross at 90-degree angles, and then all 8 of those angles are 90 degrees, otherwise 4 are acute and 4 are obtuse. It's just getting the right reason for these 2 acute ones are congruent. These 2 obtuse ones are congruent. We also have corresponding angles. So that means we want to think of these like 2 intersections of streets. So 2 street corners, and both of the northwest ones are corresponding. Both of the southeast ones, and so on, are corresponding. So here's where I've got maybe one stoplight up at this corner on a map, and here's another stoplight. So my 2 that would be the northwest corner would be angle 1 and angle 5. So if I want to say 1 and 5, one's outside, one's inside. I can't use alternate interiors or alternate exteriors. I have to say corresponding. Is that making sense? My other ones would be northeast would be 2 and 6. My southwest would be 3 and 7. And my southeast would be 4 and 8. And then I've still got vertical angles and all of that good stuff. So let's try a couple more proofs here. So copy this picture down. Don't worry about copying down the given and the prove yet, because that'll all show up in our actual 2 columns of our proof. So once you have your picture with PQRS, write down your 2 headings, statements and reasons, and your T-table. And then remember, we number under the statements and under the reasons, not just one place or the other. So we're going to write down angle Q is congruent to angle S given, and then we mark that on our picture. And then we are going to write down PQ is parallel to SR. These 2 little lines like that mean parallel. The way that I mark that on my picture, I find PQ, that's the left side, and I do a little arrow on it. And then I find SR, and I do another little arrow there. And that reason is also given. My picture looks like the top and the bottom are parallel, but I don't know that. I haven't been given that. My proof doesn't say that, so I cannot use that the top and the bottom are parallel. All I can use is PQ and RS are parallel, and I have this line that goes like that for PR. So, can I do some alternate interior angles with that? So inside would be this angle right here at P. This angle here at R. Would those not both be inside my triangle, or inside my parallel lines? One is on one side of the third line and one's on the other side, right? So these are going to be alternate interior angles, and I'll let you use AIA. You don't have to write that all out. And I need to use a different kind of tick mark symbol on there. So I'll do 2 since I've already used 1. Now I need to write those angles down, but in what I think is going to end up being corresponding order. So for my triangle on the top, I'm going to just pick any old order, but I'm talking about the one that bends at P, so P must be in the middle. So I'm going to call that QPR. QPR. And it's going to be congruent to. Now notice in the top triangle, Q had 1 tick mark in it from the given set. So the angle in the bottom one with 1 tick mark is S. P is where I just put 2 tick marks in the top triangle, and R is where I just put 2 tick marks in the bottom triangle. R in the top one has nothing marked on it yet, and P in the bottom one has nothing marked on it yet. So you see how I got those to line up in corresponding order? Okay, I want to prove parts. That means I've got to get congruent triangles so I can use Cpctc. So can I get that the triangles are congruent? Who's got an idea to help me get there? Sophia. So SAS, so let's see, am I going to be able to have 2 sides are congruent?
Well, first you can do line PR equals congruent line PR because of reflexive property.
So how am I going to get another set of sides are congruent?
So if line QP and line R, so it's not congruent, just
all we know is that they're parallel. Yes, they will end up being congruent, but that's actually what we're trying to prove is they're congruent, but we haven't said it yet. Okay? It gets confusing because all 6 things end up being congruent, but we've got to get the order right on it. So I love the idea on reflexive. We're going to use that. And I've already got 2 sets of angles. Okay? So I'm going to get my other set of angles. So that then I'll be able to do the reflexive property that Sophia said. And then I'll be able to do AAAS. I think that's what I've heard everybody say. So far, so good? But I've got to write it all down right. So now I need the other angle. So I'm going to, for my top one, now I need it to bend at R. So I'm going to take Q, put R in the middle, P. And then if I look down at the bottom, Q had 1 tick mark in the top, S has 1 tick mark in the bottom. R is the new one. So far I haven't marked it in the picture. So P is the one I haven't marked in the picture yet. And P in the top one had 2 tick marks. R in the bottom one has 2 tick marks. Now I get to mark this because I've put it in my proof. Okay, then I want reflexive property. So in the top triangle, I'm going to say PR. Now for the top triangle, P had 2 tick marks, R had 3 tick marks. So the bottom triangle, R is the one with 2 tick marks, and P is the one with 3 tick marks. So I need to say PR is congruent to RP. Now I've got all 3 of them in there. So I say triangle. top one I can put in any order I want. It really doesn't matter. So PQR is congruent to, okay, P had 2 tick marks in the top, and in the bottom, R has 2 tick marks. Q has 1 tick mark in the top, S has 1 tick mark in the bottom. And up in the top, R had 3 tick marks, and in the bottom, P had 3 tick marks. So now I have congruent triangles. After I have that in there, it is okay to use Cpctc. And what am I trying to show here? PQ, so in my top one, that was first and second. And in my second one, RS, that is also first and second, so I'm good to go. PQ is congruent to RS. And we got there. Questions from anybody on that one? Okay, turn over on the back of your notes page. And you've already got this picture and everything written down. So we're going to jump into our proof here. Statements. Reasons. On homework, you'd have to take a moment to draw the picture. And we're going to start off with the first thing that we're given, AC segment bisects angle BAD, and that is given. And I could go ahead and write my other given thing down right now if I wanted to. Or if I wanted to go ahead and label on my picture, AC bisects BAD, I could say it means those 2 angles are going to be congruent. So if I wanted to, I could go ahead and do definition of bisect here. And I could write down in that top one, angle BAC is congruent to angle DAC. And I can kind of tell just by looking at that one what order I need to put the letters in. And then maybe I ought to say the other given before I forget about it. Angle ABC is congruent to angle ADC, and that is also given. And so now let's label that. So ABC, that's up here, is congruent to ADC, that's this one down here. And these could have switched order. Okay, again, we want to get parts. So that means first we need to get congruent triangles. So I've marked 2 sets of congruent angles. So Riley, what do you think we ought to do now? I know I've got 2 sets of angles that match up.
How about the third one?
Say that again?
Then you have the third one.
So then the third one, and that is AA implies AAA. And so our third angles are both at angle C. And I can't just say angle C because that might mean this angle out here. But that's not what I'm talking about. So I've got to use 3 letters on it. So I'm going to say angle BCA in the top and angle. Now I started with 3 tick marks in the top. D in the bottom has 3 tick marks. Then I went to not yet labeled C, and then I ended at 1 tick mark A. Now I mark that on my picture. So 3 tick marks this time. Is that enough to say the triangles are congruent? Do we have an AAA triangle congruency statement? Austin? AAA says the angles are congruent?
Oh, the triangles aren't congruent yet, but the angles are.
So we've got all the angles. What else do I need to be able to say the triangles are congruent? As you look at that picture, can you tell me something else? Which side? Why? So AC in the top one is the same segment is on the bottom, so that's going to be reflexive property. So AC in the top has to be congruent to, A had one tick mark in the top, A has one tick mark in the bottom, C has 3 in both, so AC congruent to AC this time. That is enough for the triangles to be congruent with angle, 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 side. So triangle, the top one, ABC. And let's see, help me out with the order here, Clayton. If I do ABC in the top, that's 1 tick mark, 2 tick marks, 3 tick marks. Tell me what order for the bottom triangle is 1 tick mark, 2 tick marks, 3 tick marks.
Is it ABC?
It sure is. Now we have congruent triangles. Now we can say the other parts that we haven't already listed in the proof are also congruent. And the one we're interested in, BC, we find in the first one, that's the last 2 letters. DC, that's also the last 2 letters. So yes, it works. They are corresponding sides. And our reason is corresponding parts of congruent triangles are congruent. Questions with that? Let's see, what do I have here? Okay, this one aren't really going to do with whiteboards, but it is on the back of your notes paper. So let's see what we can do. So I want you guys to start off. Statements, reasons, write those givens down and mark them on your picture for me. So everybody should have those 2 statements and givens written down in your 2-column proof, and then mark those on your picture. And Lila, can you tell me where you marked statement number 1 on your picture? Where do I find those? Where's AB? Where's DC? What am I looking at? Is it an angle? Is it the top and the bottom?
Like a line is kind of like the
So the left and the right?
Yeah.
All right, so we'll mark the left and the right. Everybody good with that for statement 1? Okay, now notice AC congruent to DB. Those are kind of long. So what I may actually want to do in my paper is I may want to end up writing them separately. So here's A, B, C, and I can mark that. And then if I draw B, C, D, I might end up wanting to mark them like that so I can tell them apart a little bit better of what I'm looking at. And it's a little bit hard when I mark this. Am I talking A to this point where they cross, or the whole thing? And it is okay in your notes to recopy it as 2 separate triangles anytime that is less confusing. Okay, we just want congruent triangles here. And I've got 2 sets of sides. Look at all 3 pictures. Is there a way to get side, 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 angle, side? I don't think HL is going to work. Or angle, 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 side. James, what are you thinking?
BC equals BC because it's on both in this reflexive property.
So in the original one, those are the same thing? So I'm going to be able to use my reflexive property for that bottom side, which is BC. Now I have to figure out BC is congruent to BC or BC is congruent to CB. Which way do I need to write it? So I look at my pictures. B looks like it's obtuse to C, but when I go with the other one, B doesn't look like it's the obtuse angle there. So I need to switch it to CB. And that's also going to be so it matches up in what I'm trying to go to. BC is congruent to CB. Okay, so then if I also mark it on my separate pictures, do I have enough that I can say the triangles are congruent? See a bunch of heads nodding. Shout out, what's the reason? SSS, I've marked all three sides on my pictures. And so triangle, I'm going to copy it in the same order they had here, ABC, is congruent to triangle DCB.